Here, this is going to be the second example of the Raphson method, but this is going to be a weird example, a particular one. And the reason why I want to make this example with just two iterations, and which is going to be a particular one, is that I want to show you something important. Okay, so let's start with this function. F of x equal to x squared minus x minus 2. And if you're good in calculus, you will probably recognize that this is a parabola. Let's start with x of 0 equal to 2. So if you remember, what we gotta do, well, let me just write it once again, just to be sure. All right, for the Newton Raphson method, we have x to the n plus 1, x to n plus 1 equal to xn minus f of xn over f prime of x1. All right, so basically what it says is that first thing first, well, we're gonna find, you're gonna write down the f as our function. So our f is actually x squared minus x minus 2. We're gonna have to find the first derivative. So first derivative is 2x minus 1, then that's it, because 2 goes to 0. All right, so basically, once we have done that, we know that the initial value is of x0 is going to be 2. So we start with x1 by computing x1. Okay, so now that we are going to compute x1, we start with 2, right? Which is we start with the xn, so which is 2. So it's basically the n that the x that we have at the previous step, but there is no previous step, there is only the initial value, so it's 2, minus the value of basically the initial function, so this function here, in the value of x, so in the value of 2. So we basically substitute 2 and plug in back 2 into our function. So basically we have 2 squared minus 2 minus 2 over, and we do the same thing, but this time we plug 2 back into the first derivative. So we have 2 times 2 minus 1. This is actually going to give me 2 minus 4 over 4 minus 1, which gives me 2 minus 0 over 3, which is nothing, so it's basically equal to 2. All right, so we have just found 2 again as our x1. So we go on and we say, okay, let's try with x2. But hold on a second, isn't it the same? So we basically say, okay, xn, the former value for x, which is 2, so it's 2, minus 2 substituted in the function, so this one, which will be 2 squared minus 2 over, we substitute 2 into its first derivative, so this one, and we got 2 times 2 minus 1, which is 2 minus 4 over 4 minus 1, which is 2 minus 0 over 3, which is 2. And we say, hold on a second, we found 2. If we try to find x3, we're going to find 2 again. And x4 is going to be 2 again. And x5 is going to be 2 again. Hold on a second. Why are we still getting the same number after going on and on and on with the iteration? Well, this one, my friend, is a parabola. And actually, it's basically going through the point to 0. So it's actually passing through the point to 0. So when we find 2, we stop, because we have actually found the point in which the parabola is going to pass. So it's not a big deal that the iteration gonna output the very same number all over again, because this very number, my friend, is actually the result. So basically the point in which it's going to intersect. So that's pretty much it. I mean, it's we don't actually have to go any farther and do x 3, 4, 5, 6, 7, x to the 1000 and so on. We're still gonna get 2. So we stop. We're fine. We're good. So I promised you that it was going to be weird, but weird in a good sense, not in the bad sense. Meaning that sometimes things can go really, really well and can be really sweet. So that's pretty much it. I'm gonna make another example, by the way, but in another video. So stay tuned.